This is the third video of Module 9. I discuss various service delivery models in this video. Let me give you a summary of the case so that you understand the context of this video. IVK, the company of our case, is going through a vendor selection process to develop its new backend system. There are three finalists: ServoLith, VerxaWeb, and HiOSoft. Each company suggests a different service model. We want to have a better understanding of these various service models. To understand IT service models, we need to know the taxonomy of computational resources. The first class of computational resources is hardware that includes resources such as CPUs, RAM, storage, and network interface cards. Operating system, the second class, provides the ability to execute multiple applications and processes from multiple users and also share hardware resources among those applications and processes. Examples are Linux, Windows, macOS, and Android. A runtime environment is responsible for executing the codes written in a specified language on different operating systems. Before having a runtime environment, a code that was compiled for Windows could be executed only on Windows, not on Linux or another operating system. A runtime environment allows the code to be quite portable. Therefore, a code written in Java language, for example, can be executed on any operating system as long as a runtime environment for that operating system exists and is installed. A runtime environment can allow language interoperability as well. Almost all languages supported by Microsoft, such as C# and Visual Basic, need .NET CLR to execute the code. Consequently, one programmer can develop part of the application code using Visual Basic, and another programmer in the same team can use C# to develop another part of the application. Since both are executed in CLR, they can call one another and communicate. Another example is Python.exe that interprets your Python code by transforming it into CPU-readable bytecodes. A software framework is another class of computational resources. It's a collection of libraries of codes that make programming and developing a software application easy and fast. Examples are web frameworks such as Java Servlet, ASP.NET, and Python Django that make developing web applications faster and easier. Finally, the last class of computational resources is a software application, such as a Gmail and Acrobat Reader that use different uh, frameworks and a runtime environment. But as a user of these applications, you do not know what goes behind the scene. Some software applications do not use a framework or a runtime environment. Uh, Keep that in mind, especially real-time applications that should react in milliseconds. The previous taxonomy can help identify various IT service types in the market. The first service type is software as a service or SaaS. As a client, you get access to an application such as Gmail or Office 365, but you have no control over the framework, operating system, or hardware. You cannot change the logic of that application either to fulfill your unique requirements. Only the service provider can change the logic. You can only control the data entry and updates in those applications. The second service type is platform as a service or PaaS. It has two subtypes. With the framework as a service, you pay for using a hardware that is equipped with an operating system, a runtime environment, and a framework such as Django for Python web application. Therefore, everything is ready to run your Django codes and website. While it is easier to manage Django supported websites, you cannot install other Python web frameworks yourself. The application development is controlled by the service provider. On the other hand, with the runtime environment as a service, you can install any frameworks you deem necessary as long as the framework is supported by the runtime environment. If the runtime environment as a service only supports Python.exe and you need Java virtual machine to run Java-based applications, you cannot install that yourself. If you want to have full control over software installation and deployment, you need to go for infrastructure as a service or IaaS. The operating system as a service will allow you to use a computer hardware with an installed operating system such as Windows or Linux. You will be in charge of installing deployment environments, frameworks, and software applications. However, with hardware as a service, you can even choose the operating system and change or update it if needed. The traditional approach, however, was to ask for application development, and the client was in charge of hardware, operating system, and everything else. So you would just receive a source code and some executable files, and you were in charge of everything else. Another traditional approach was buying an off-the-shelf software product rather than asking for developing a software application. In this case, service was limited to a help desk that guided you on how to use or troubleshoot the software application. There are 6 deployment types as well. That is 6 ways to make a software application or any computational resource available for use. These models are based on 4 attributes. The first attribute is the location of computer resources, whether the resources are located within the wall of the using company or the resources are located in the premises on the premises owned by the service provider. The second attribute is who owns the computer resources, the using company or the service provider. The third attribute is who manages and maintains the computer resources, the using company or a service provider. The last attribute is who else uses those computational resources. Only the company uses them, or there is a community of companies sharing the computational resources, or the resources are open to public and are shared by anyone who pays for them. In the traditional approach, the company owned and managed the computer resources located inside the walls of the company, and no one else had access to them. With the IT service outsourcing, the management, development, and maintenance of these resources were moved to an IT service provider. With the on-premise private cloud model, the ownership is also moved to another company called a cloud service provider. With a dedicated private cloud model, the resources are also moved to the location of the cloud service provider. Finally, to decrease cost, the cloud service providers allowed more companies to use the shared cloud. And with a public cloud, the computational resources are shared with anyone who pays for them. Now we can figure out the service type and deployment model of the three finalists. ServoLith suggests a SaaS service type for a monthly fee. It follows a shared cloud deployment model, as apparently ServoLith has a plan to allow other companies to use that software as a service as well. The proponents of ServoLith believe that IVK should not be in the business of running data centers and developing basic software systems. Therefore, it is better to move all non-essential data and services to ServoLith. Moreover, ServoLith has way more experience with those functions in the backend system as it has worked with many other clients on those functions. IVK will never be more expert in those areas. Also, in the long run, IVK can save money as the service is shared by several companies. However, there are some disadvantages as well. So, ServoLith keeps the data and controls IVK's access to the data and systems. If ServoLith is unresponsive, uh, incidents such as the one that happened a couple of months ago to IVK can cripple IVK. There are some security concerns as well. Employees of ServoLith can have access to the data. They can go rogue and sell the data to IVK's competitors, or as a client of IVK, perhaps they can change the data to their benefits. Moreover, ServoLith may market the functions developed solely for IVK to IVK's competitors, which means IVK will lose its edge over those competitors. VerxaWeb suggests a traditional service type, where VerxaWeb is in charge of the application development. However, they are open to IT service outsourcing, where they manage the applications located on IVK's premises and computers. The advantage of this service delivery model is the full control of data and services. So you're not worried about data leaking to your competitors, or uh, issues that can happen because of a third party having access to your data. The disadvantage is that this approach can be comparatively more costly in the long run, as IVK solely pays for the computational resources. Also, uh, this approach requires more time spent on system management. Finally, HiOSoft does not want to provide a service. It just wants to sell a software package. IVK has to contract separately with the web of partners of HiOSoft and can go for any service type and deployment model. This gives IVK the maximum flexibility. IVK can go for platform as a service or infrastructure as a service cloud. The disadvantage of this approach is its maximum relationship overhead. IVK has to make many decisions, which was the reason for the previous project failure and the analysis paralysis of that happened there. Moreover, there is no one throat to choke. When responsibilities are divided among several companies, things can easily go wrong as these companies try to place the responsibility for a change or an incident response on the shoulders of the other parties. Now that you understood various service delivery models, pause here for a minute and answer this question and this one. In the next lecture, we discuss standardization and innovation.